Hi guys, so we have our data in this raw layer, which is dirty, not trusted, and we know that we want to convert it somehow into this nice dimensional model that contains facts and dimensions. And based on the last episode, we know that we might use multiple layers between these two, depending on our case. But how do we transform our data? What service to use? Well, that's the topic for today, so let's get started. Alright, so we have to transform our data. And in Azure, there are multiple services that could be used for this purpose. Today, I would like to talk about my first choice, which is Azure Databricks. And please note that Azure Databricks, it is a huge service. It has a lot of features, and for sure, there will be multiple episodes about it. So don't worry, it is not the only one about it. So let's start discussing this wonderful thing called Azure Databricks. Alright, so we've got Azure Databricks. What is this stuff? Azure Databricks. Databricks or Databricks, however you want to call it. So basically, this is how Databricks describes themselves, that they created basically a data and analytics platform. So it's not a tool used to do a single thing in our BI landscape. No, it is a whole platform. And in a second, I will tell you what they mean by this. So this is our data and analytics platform, and this platform is important. In the past it was different. In the past, Databricks was used mainly just to transform your data. That's the case that we'll use it more often. But in time they started to add new features into this Azure Databricks thing, covering various aspects of data processing, which turned this single tool into the whole platform. And if you go through documentation, you will find information that there are various use cases where Azure Databricks might be useful. So let me quickly go through them. So the first use case they describe is to build enterprise data lakehouse. So build enterprise data lakehouse. And I already mentioned this data lakehouse thing, and then I told you that it required some software to be made available on the market that we used on top of our data stored in a data lake. And that, in this case, this is Databricks, which made this data lakehouse thing possible. Data lakehouse. And don't worry, we'll cover this use case. Not today, in one of future episodes. So that's the first use case. Then it can be used for ETL, extract, transform, and load, and data engineering purposes. Data engineering. And that's the thing that we'll focus on the most often. It can be used also for machine learning, AI, and data science. It has capabilities to do so. And that's the stuff that we will not cover at all. It's not in the scope of the exam, so let's just skip it. But it's good to know that this type of activities can be done in Databricks. So data science. Apart from that, we've got data warehousing. Data warehousing, analytics and BI. Analytics and BI. Then we've got something that is often missed in our data solutions. So let's say that we have our data already ingested, transformed, and presented to end users. But how about governance of this data? How to protect it? how to make sure that it is accessed in a proper way, how to share this data. And Databricks has an answer for this, because it can be also used for data governance and data sharing. Like so. And the last thing I want to talk about is streaming. So far I was talking only about batch processing, which simply means that we are running our processing, let's say once or twice a day, usually during the night, to not cause any impact on the source system. But nowadays there are more and more sources and solutions that produce streaming data that has to be somehow processed, and Databricks can be used to handle this. So streaming analytics, and we'll get back to streaming at the end of the whole course, so we'll get there. For now, let's just focus on the batch processing, which is still the majority of solution types, at least from my experience. Analytics. So as you can see, we've got many use cases where this Databricks thing could be used. And if you go through documentation, and I can encourage you to go at least through the overview page from Databricks, it is indeed a platform. It can be used in various places inside our BI solution. Alright, so let's continue talking about what it actually is. Is it a part of Azure only? Is it a Microsoft product? And the answer is no. Databricks is a separate company. And this is important. So this is a separate company. It is not a product that was created by Microsoft, no. So basically, from a historical point of view, it was like this. So we have this Apache Spark thing, Apache Spark, and Apache Spark is this open source, let's call it framework, to process big data in an efficient way. And it is still there, it is still maintained, it is still widely used. The problem was that it wasn't that easy to use it. It wasn't that easy to learn it, how to install it, how to configure it, how to write your transformations using pure Apache Spark. So simply put, the learning curve of Apache Spark was quite steep. And I think that even today, it's not that easy to find developers who would be experienced in using pure Apache Spark. And there were various guys working on this Apache Spark thing, and they saw those issues with this vanilla Apache Spark. And what they did, well, they thought, all right, let's create our own company that will use Apache Spark. We'll build a software on top of Apache Spark, and because we know Spark very well, because we created it, we know what issues it had. We know how to make it better, how to make it faster, how to make it more performant, how to make it easier to use by users. And that's what happened. So those guys, they left Apache Spark and they started this Databricks company. Databricks. And indeed, they created this software, the Databricks thing, and they thought, all right, but how do we host it? How do we make it available to end users? And simply, they decided to make it available in various clouds. So not only in Azure, but in all major cloud vendors, providers like Azure, Amazon, and Google. So in every of those clouds, you might find a Databricks, which means that Databricks is a multi-cloud solution. Multi-cloud. Which in turn means that if a company decides to use Databricks to write some part of the solution, then if they decide, hey, we need to move from this cloud to another cloud, it should be possible, at least in theory, without major changes. Because Databricks, it exists in various clouds. Of course, those instances of Databricks, they will differ a bit between every cloud. So some changes will be necessary, but the majority should work just fine, which is a nice thing for business, which usually don't want to log to a specific cloud. Now, the reality is that apart from Databricks, their solution, they usually use some other services as well, so the migration might not be that easy. But at least in the Databricks part, it should be possible. Alright, so we know that Databricks is not a Microsoft product. It is a separate company that just made their software available on Azure. Which means that when we come to a billing part, how much you have to pay for it, you will pay both to Microsoft for using their infrastructure and to Databricks for using their software. And that's important to know, just not to be surprised by the bill. Alright, so that's the overview of Databricks, what it is, how it started. So let's try to position it inside our typical BI solution. Alright, so let's draw it one more time. And let's try to find a place for Databricks. And I know that I've been drawing this diagram multiple times, but it's good to know where given service fits in the overall architecture. So, as usually, we start with various data sources, like files, CSVs, JSONs, XMLs, and so on. We've got various databases as our sources, those on-prem, in the cloud, and so on. We've got various APIs, basically all types of data sources you can think about. And we know that at the beginning, we just want to load it into a data lake. So let's say this is our ADLS Gen 2, like so. And it goes like this. So the data is ingested into data lake, and we know already that we can use various tools to do this ingest part. And the tool that I like the most, that works very well and handles most of the cases, here is Azure Data Factory. So, Data Factory. Apart from this, we could use Logic Apps or pipelines in Synapse. But for now, let's assume that we are using Data Factory. Then, inside our data lake, we know that we have to split our data or organize it into various layers, just to avoid this mess. And the first layer to which we dump our raw data is called raw, and that's something we did in the past. Now, once the data is already there in our data lake, we want to start transforming it, applying business rules, cleaning it, removing some invalid data, handling nulls, handling duplicates, and so on. And that's the place where Databricks can be used. So let me draw it just above our data lake. So this is Azure Databricks. And in our case, we'll use it in this scenario. It will be used to read data from our raw layer, do something with it, transform it somehow, and then save it back to our data lake. And we might repeat this process depending on how many layers we'll have in our data lake. So Databricks here, it is used just to connect to data lake, grab the data, do something with it, and then save it back. So simply put, this is our transform phase. transform phase. And that's where Databricks is very good at. So that's the place where I use it the most often. Alright, but you might say, but in the past, I did all those transformations inside of my database. So why should I switch to Databricks? And that's a valid point. So let me describe how it looked in the past, in the good old days. So before big data, what was usually done was like this. So we had some kind of a database, usually on premises. So this is our database. It could be, for example, SQL Server. That's the tool that I used very often when it comes to BI solutions. And what we did in the past was to simply write various queries or stored procedures inside this database that were used to transform the data. And it worked quite well. The problem was when the amount of data started getting bigger and bigger, and simply put, this machine on which my database was located wasn't able to process it in a time window, let's say during a night. Simply the amount of data was too big. And what was done then was to simply, alright, let's deploy our database on a more powerful server. So let's represent it by just drawing a bigger database like this. So what we did was to simply scale up our machine. Like use a better CPU, add more memory, add better, faster disks, and so on. And for some time it was enough. The problem was that such solution was quite expensive. So our small database, alright, it was relatively cheap, but once we tried to scale up our hardware, it became expensive. And it might not be enough for the processing power to be able to process all the data that we had to process. And at some point, we reached a limit. So simply put, we couldn't scale up our database even further because it wasn't physically possible. And what smart guys thought of was, alright, so instead of investing in a scaling up solution, when we use more powerful single machine, let's just split the workload into multiple worker nodes. So let's just have a bunch of machines that will do the work. And because each of those machines will get a small portion of the whole work, it should be faster and cheaper, because they could be just a commodity hardware, just a regular machines, nothing fancy. And how does it look like? And by the way, that's how Apache Spark did it. So what I'm going to present right now is the high-level architecture of Apache Spark and the Databricks, because Databricks is built on top of Spark. So in this case, we have something like this. We have a single node that is our brain, our driver, and we've got a bunch of worker nodes. And their number, well, it depends on our configuration. So the one on top, this is our driver or brain, how I like to call it. And those below, these are our worker nodes. Worker nodes. Or simply put, our muscles. Like so. And then what happens is that, let's say we have someone who would like to run some processing. Let's say this is me who would like to run some query, some transformation on this thing. And what I do, I just send it to the driver, to the brain, which is an entry point to the processing. This driver, it splits my request into multiple parts and distributes it to various worker nodes, like so. Then each of those worker nodes, it does its part of the job and then returns the data to the driver. And once it is done, driver simply sends the results back to me. And that's how it works. So we have this distributed architecture. So no longer we have a single machine doing all the stuff, doing all the work. No, we split it into multiple ones. And the best part of it is that this distribution of work happens automatically. We don't have to care about this. Well, we have when we want, if we want it to be fast and efficient, but in general, it is done for us. So what the approach was done here is that instead of scaling up a single machine, we have a scale-out solution. So we just provision multiple worker nodes that are quite cheap because they are just regular machines with pre-installed software that allows the Databricks to work. And that's it. That's how our Databricks looks like. That's how Spark works. And the stuff that I just drew, this driver brain and worker nodes, this is simply our cluster that we'll use to run our queries, our transformations. And you can think of a cluster as our compute layer. And we'll provision cluster quite soon. Now, what is also important is that in Databricks and in Spark, we have a separation of compute from storage. So we have a cluster that has all those machines and the software, but the storage is separated. So our storage is here. And obviously, each of those worker nodes, it is able to read and write our storage. And in our case, in the case of Azure Databricks, for storage, we use Azure Data Lake Gen 2, which we know is Hadoop compatible, which, to simplify, it is able to talk with Spark. It is able to understand it, and just it can be used as a storage layer. Alright, so that's enough theory for now, and let's jump into Azure Portal to start provisioning this stuff. So let me jump to Azure Portal and let's create something called Azure Databricks. If you don't see it here, just type Azure Databricks and create something called a workspace. And obviously we have to fill various stuff, like always subscription and resource group. We've got to provide a name for our workspace, and simply workspace is our instance of Databricks that we'll use later on to create various clusters and to run our processing there. So let me call it demo dp23 Databricks 1. Let me locate it in West Europe, and here the pricing is something important, because you'll see here that we've got various options here. We've got standard, premium, and trial. And trial says that it has something free for 2 weeks. But please note that it offers only free DBUs. And we'll get back to it, what it is, those DBUs things, and how do we pay for Databricks. For training purposes, just go with trial, but please be aware that it is not completely free. You will have to pay for something, so please be aware of this. So let me go with the trial. Then we've got various options that I will skip for now. Let's just create a hello world scenario. And let's just wait a few minutes for this Databricks thing to be provisioned. Alright, so our Databricks workspace has been created. So let's go to it. And here you can see we've got something called Launch Workspace. So let's click on it. And please notice that this will be our interface, our UI to work with Databricks, at least for now. And secondly, please note that its look and feel is different from Azure Portal. So why? Well, simply put, we left Azure. Remember, Azure Databricks is a separate company, and this portal that we are using right now, it is hosted in Databricks, not in Azure. So that's why it differs. Alright, so let's quickly go through the UI, how it looks like, and what you can find here. And please note that Databricks keeps changing the user interface. And if you take a look at various tutorials or some other videos, you might find the UI looking completely different. Don't panic, they just do it every now and then, move stuff around. But you should find those options somewhere. Alright, anyway, on the left hand side, we've got various menus, various links to various options. And for sure, we'll go through this generic part. That's where we gonna create our notebooks, our clusters, and different other things. We've got something related to SQL warehouses. We'll cover that in the future. We've got something for data engineering, and we might cover this as well. And we've got stuff for machine learning, and that's the part that I won't talk about at all. So let's ignore it. Now, today I would like to just focus on a hello world scenario. So let's create a simple transformation. And you know from the diagram that we need to have the compute power to run our transformations on something. And the place where we're gonna create our cluster is this compute option. So let's go there. And we've got various options here. For now, let's just ignore all of this stuff and let's simply create our compute, our cluster. And now, this page is super important because that's the place where we're gonna configure our cluster, and depending on our choices, we will have access to various features, and it will highly impact the price, how much we're gonna pay for this. So let's start from the top. Let me rename the cluster like so. Then we've got policy dropdown that we can use to restrict the power of the cluster that we're gonna create. That's for future. Basically, the goal here is we might want to allow our users to create clusters on their own, but we want to restrict it somehow so they don't provision a cluster that contains 20 nodes that are super expensive. That's where policies can be used. Then we've got a super important choice whether we want to create our cluster as a multi-node or a single node cluster. And what does it mean? Well, if we go back at our diagram, so this is our cluster. If we want to have those multiple worker nodes, then we have to choose multi-node option. And then we'll be able to decide how many worker nodes we want to have. But obviously, the more worker nodes you have, the more you will pay for it, right? So if you want to lower the costs, then you might go with a single node option, which will create only this single driver node. And all our executions, all transformations will be run on this single node. For training purposes, or where your workload is small, I suggest to go with single node because it is cheaper. And please note that depending on the choice, some parts of the UI just disappear. So take a note here at this worker type. If we switch to a single node, it disappears. Why? Because this worker type, this thing, it is used to configure how our worker nodes should look like. So first of all, we could say, alright, what type of Azure virtual machine we want to use as those worker nodes. So basically, how powerful each of those nodes will be, how many cores it will have, how many memory it will have. And obviously, the better VM, the more you will pay for it. And then you can indicate, alright, how many workers you want to have. You might have it as a static value, like always have 4 worker nodes, but you might want to configure it in a dynamic way, so between 2 and 8, depending on a workload. And if you go with this dynamic setting, then it will be up to Databricks engine to determine when you need additional workers. And if such case is detected, Databricks will automatically provision a new worker node for you. So that's a cool thing. Then we've got something about spot instances, and I will talk about it in a second. Alright, but for now, let's just create a single node, and here those settings about worker nodes, well, they disappeared. We still have a configuration for our driver node, and let's go with the standard DS3 v2 VM because it's fine. It has 14 gigs of memory, 4 cores, that's fine. Alright, then let's go with the access mode. What is this thing? And this is important. So right now we've got 3 access mode: single user, shared, and no isolation shared. So how do they differ? So let me draw it. They were called how? Access modes. Alright, so access modes. You've got cluster access modes. That's yet another important decision that we have to take when we create our cluster. So the first option we had was called single user, and the tooltip describes it quite nicely. So for single user, you can run workloads using various languages like SQL, Python, R, and Scala, but as a single user, and that's important. So we have the single user mode, single user, and my cat just keeps making noise, so I've got to let it out. Alright, so single user mode. So we had, in this mode we have all languages, and in a second I will show you what I mean by this. All languages, but it is meant for a single user only. For single user. So if it is you who wants to play around with Databricks, go with the single user mode, that's fine. But if you have a team of data engineers or data scientists who would like to work with this cluster, that it will not work for them because it allows for access only for a single user, like for me. So no, if you have a team of employees, then a single user is of no use. And in the past, this single user mode was called standard. And you might find those old names in various places in a documentation or in some other tutorials, so don't be confused. Basically, single user means standard from the old days. As I said, Databricks likes to change things. So that was the first access mode type. The second one that we have is called shared. And here we've got some other workloads, languages. So shared mode. Here we can run our Python, our SQL transformations, and optionally Scala. But to run a Scala on a shared cluster, we have to configure it in a specific way. Namely, it has to have this Unity catalog thing enabled. And I know you don't have a clue what a Unity catalog is right now. Don't worry, we'll cover that in the future. Just please be aware that Scala might not be available on a shared cluster. Depends on the configuration. But if you have a team of users, multiple employees that would like to reuse a single cluster, and usually that's what you want to have, then the shared mode is for you, because it allows to be used by multiple users. For multiple users. Furthermore, it allows for isolation of those users. So let's imagine that we've got 10 data engineers and one of them runs a workload that requires a lot of resources. So it might use all of the cluster power. And in this shared mode, it is handled by Databricks. So this single workload will not consume or will not impact other users using the same cluster. So those workloads are isolated. And in the past, this mode was called high concurrency. High concurrency. Again, old name, but the behavior is pretty much the same. And we've got the last mode called no isolation shared. But here you can see that there is no isolation between users. That's important. So here they might impact each other. So the third mode we have is no isolation shared. No isolation shared. And here I believe you can use all languages, but you don't have isolation. No isolation between your workers, between your team members. And by default, if you have a team or group of people who needs to access the cluster, go with shared mode. That's the option that works well in many cases. But for me, because it is only me that will be using this cluster, I will go with this single user mode. That means that this cluster will be usable by me, by Piotr. Alright, let's go to performance tab. So we've got something called Databricks runtime version. And think of it like this. So Apache Spark, the software that runs, that is used by Databricks, it has its own releases. And also Databricks has its own releases. And here on this drop-down, you can select which Databricks runtime, which basically means which software version of a Databricks you want to use. And usually, you want to use one of those versions marked as long-term support, LTS. So you can be sure that it will be supported for a few years. And then next to each version, you can see which Scala and which Apache Spark version is supported in this version of Databricks runtime. So let's say you would like to use the latest Spark version, 3.5.0, and then choose the proper runtime of Databricks. So we've got those 4, and out of those 4, I would go with the one that is marked as long-term support, which is this one. If you are into machine learning stuff, you can choose one of those runtimes for machine learning. But because I am not interested in this stuff, let's go back to standard and let's go with this one. Then you might use photon acceleration, which at this point, let me just say it's a thing that makes your workloads run faster. That's it. Without going too deep into details. So you can set it or not. But please know that whenever I click on something on this UI, on the right hand side in the summary, something changes. So take a look here. With Photon enabled, we've got this tag of Photon, obviously, and we've got 1.5 dBu per hour mentioned. If I unclick it, this dBu drops by half. So what is this dBu per hour? So basically, that's how much you're gonna pay to Databricks for using their software. And the pricing that Databricks has, well, it uses those dBu things, Databricks units. And depending on various configuration stuff, the price of dBu per hour, it might vary. In our case, we are using this all-purpose cluster, premium tier, which means that we'll pay $0.50 per dBu hour to Databricks. So if we choose Photon, then the price doubles, right? So pay attention to this summary tab, because it shows you how much basically you will pay for this cluster. In my case, I don't want to have Photon. I don't need it at this moment. Let's go with this. And then the most important thing, or one of the most important things here, is that basically we want our clusters, our virtual machines, to run only when we need them. Because whenever those VMs are up and running, we're gonna pay for them, whether we use them or not. So we want to make sure that they will be shut down if not needed. And this terminate after something minutes is the option that will help us to do this. So basically here I like to set it to a very low value, like 15 minutes, which means that if there is no activity on this cluster for 15 minutes, then it will automatically shut down, which means that I will no longer pay for the VM. Which means that if we go back to our cluster, we can stop it and we can start it whenever needed, right? And because we have this separation of compute from storage, we can safely stop our cluster and the data will be still there, because data is stored separately on a data lake. And if we have data factory that would like to ingest new data, it will still be able to do this, because it will just connect to our data lake and write data there. In old days, if we tried to take our database offline, the data will not be available anymore, because they were tightly coupled, compute and the data. Here we have this separation. So the very important option that you want to set is this auto terminate stuff, just to make sure that you won't pay when you don't use your clusters. So auto terminate, and please don't forget to turn it on, to set it, because you might be surprised by the bill. And usually my recommendation is go with this setup that I just shown here. It won't cost much, and in many cases it will be just enough for you to play around with Databricks. Remaining advanced options, let's just ignore it and let's just create the cluster. Now it will take a few minutes to be created, and in the meantime let me talk about this spot instances thing that we saw when we had an option to create this multi-node cluster. So how does it work? So let's imagine that this is a diagram of a capacity in Microsoft Data Center over time. So this is capacity of virtual machines, because those worker nodes under the hood, they are just virtual machines. And depending on customers in a given data center, how many VMs they wanted to have, this capacity might vary, like so. Maybe that's the workload. So those VMs are provisioned and used by customers who pay for those VMs. Now, the thing is that Microsoft has to be prepared for customers who want to create a new VM. So inside a data center, let's say that this is their full capacity. So they have to have this free space for VMs just waiting to be used by customers. The thing is that those idle VMs, they are not for free for Microsoft. Microsoft has to pay for power, for maintenance, for hardware. So those not used VMs, they just generate costs. So what Microsoft decided was, all right, let's offer VMs from this capacity unused at a given time. Let's offer it to customers at a lower price, much cheaper than a regular price. So we won't be losing money on those unused VMs. But there is a catch. If one day there is a huge demand from regular paying customers, then if you have a VM here and the workload or demand is super high for some reason, maybe it's a Black Friday, so that's the demand that reaches the full capacity of the data center, then your VM might be evicted. You will be just kicked out from the data center because other regular customers want to have this VM provisioned. So that's the risk you have to be aware of. Now, in the case of Databricks, this tooltip says that if there is high demand, your spot instance, and spot simply means those VMs created from this orange unused capacity, they will be replaced by a regular VMs. So it will be still working, but you'll just pay a regular price, which is quite nice. So in general, on dev environments, when you don't care that much about high availability, you might be fine with going with spot instances. For prod, you might need to analyze it a little bit deeper, whether that's something that you are okay with. All right, so let's take a look at our cluster. Did it create? Yes, it's up and running. All right, so let's finally do something with this cluster. So what I'm going to create is something called notebook. And notebook is a visual way which we can use to write our code. And we'll cover notebooks in future episodes. For now, let's do a very simple hello world scenario. So basically, in our notebooks, we have multiple cells. In those cells, you would just write your code. Python, Scala, R, or there's one more language, and then you'll just execute those cells one by one, and that's it. And the nice thing about notebooks is that they can combine your code with the results and some markdown that you can use to provide some description. Now, every notebook has a default language. For me, it is set to Python right now, but you can switch to Scala, SQL, or R. And that's yet another great thing of Databricks, that you can switch to the language that you like the most. For me, it's SQL, but maybe for you, it's Python. And because you have this freedom, then the audience of Databricks is quite wide, because it can be used by SQL guys, by Python guys, and so on. Later on, we'll go deeper into how you can switch those languages and exchange data between them. For now, let's just create a very simple notebook. So what I would like to do today is this scenario, this. So let me just grab some data from our raw layer, this replicable data that we read from API. Let's just take a look at it without any transformations, and let's just save it back as delta. That's it, nothing more. So it would simply reflect what Microsoft says in their data lake design. We'll do like this. So we have our raw data, and we just save it as analytical format inside this conformed container. That's it for today, nothing more. All right, so the first thing we've got to do is to somehow connect to a data lake from Databricks. And by the way, did you notice how easy it was to provision this Databricks workspace and a cluster? It just took me a few minutes and I'm done. I'm ready to start working with Databricks, with Spark. It was super easy. It doesn't require any knowledge at this moment. Of course, it is possible to fine-tune this whole setup, but it's not for today. Anyway, let me connect to a data lake. And if I go through Azure documentation for Databricks, I will find multiple ways I could use to connect to a data lake. We will go through this in future episodes. For now, I will go with the fastest method and the worst one. Namely, I will use the account key. And you should remember that account key from a storage account, it gives full admin permissions. So a very bad idea to use it. Don't do this in real life, but because it is so fast, let me just go with this. So let me copy this code snippet. Let me paste it into this first cell and let me modify it. So what this code does? Well, it sets some configuration for my session without this notebook, which tells that, hey, whenever you want to connect to this storage account, and in a second we'll set it to my storage account name, then use this particular access key to get access to it. And we will make it even less secure than the placeholder here, because I won't be using any secrets. I will just put a hard-coded value. Very bad thing. Don't do this. But just to make it faster, let's go with this. Alright, so this is my storage account name. So let me paste it here. And here I've got to paste my access key. So let me go to access keys. Let me get this value. Don't show it to anyone. I will rotate it after recording this video. And let me paste it. Alright. So it simply means, hey, Databricks, whenever I would like to connect to this storage account, simply use this access key for authentication. And that's it. Now, to execute this cell, just use this run cell button and make sure that it is attached to my cluster, the one that we just created. So let's run it. And let's allow for some pop-ups. And it's done. So the first command has been executed. It just means, alright, in this notebook, this specific access key will be used to connect to this data lake. Alright, but how do I grab my data? So let's go through the documentation, and they say they have some examples that in Python, and that's the language of my notebook, they say, alright, just go with this Spark read load option and then provide a path to your data. So let's use it. So let me add another cell. Let me paste this code snippet, and let's provide a path. This ABFS thing is just a protocol, secure one, used to connect to a data lake. So for sure, we've got to indicate which storage account we have in mind, then what's the container name which contains our data, and in our case we want to go to raw container, to rubricable, minifix, and then this minifix JSON. So let me grab this stuff. The container name was raw, and then at the end we've got to provide a path to our data that we want to read. And you had this rubricable, minifix, and at the end I think it was minifix.json, like so. Yep, it should be fine. So let me now execute this cell, only this one, just by using this run button, and let's see what happens. And it failed. It failed because it says that it is incompatible format detected. And yes, that's true, because by default Databricks uses Delta Lake format. But here we've got JSON. And of course those two formats are not compatible. So let me fix this code and indicate that I want to read it as JSON. So in this case, I will just add indication what type of format I want to use. Hey, it is a JSON file. So, like so. And let me run it one more time. And it is doing something. Alright, it was a success. So some data was read. Alright, great, but how can I see this data? What can I do with it? Well, to make it work, I will assign the data that was read to an object called df. And df is, in my case, just a name of my data frame. And in Spark, in Databricks, you can think of a data frame like something similar to a table that has rows and columns, representation of your data. So if I run this cell, then the content of the JSON file will be available in my data frame called df. And here below, you can see the structure of this data frame. So Databricks was able to go to this JSON file located in a data lake. It detected its structure, that it has this current, next, and previous fields, and then it has an array of something called a struct. And right now think of a struct like a set of columns, like an object. That each of those structs have various fields like last modified date, name, number of parts, and so on. Now, if we revisit the original file, this minifix.json that I have opened in Visual Studio Code, you'll see that indeed that's the structure of the JSON file. We have those regular fields, and then we've got this array of JSON objects. So our Databricks code was able just to read this JSON file very easily with a single line of code and understand its structure. Super cool, right? And that's one of the great things inside Databricks, that it allows us out of the box to read various file formats like JSON, like Delta, CSVs, Parquets, orgs, and so on. If there is any format that is not natively supported by Spark and by Databricks, no problem. You can just import some library that handles this file format. Great. Anyway, so how can we take a look at this data? Because right now we just see the structure. So let's add yet another cell, and let's use a command called display. And the display is used simply, well, to display something. In our case, we want to display our data frame, just to see what's inside. And please note that I used the data frame that was created in the previous cells, which means that I can reference some objects, some variables from other cells that were executed previously. Now, let me turn on new table view, which will display our data frame, our JSON file in a nicer form. And here you can see it in a tabular way that is clickable, interactive. And indeed, we can see that every row here from our table, it represents a single page that we got from the Replicable API. Great. And this data that we care about the most is stored in this results array. And you can see here that indeed this is an array, and each of the objects contained in this array, it contains various fields that we would like to parse later on. So probably what we would like to do in the future would be to grab all of those things and make them irregular columns, like those fields. Because working on those arrays by data engineers or by report builders in the future is not the best experience. We want to give them just a regular table with just simple rows and columns without any nested complex types. But that's for the future. Right now, let's just save this data back to a data lake as delta. Alright, and how can we do this? Well, let's grab this command and let's update it to simply write our data back. So I will use df because as the beginning, because we want to do something on our data frame. Then we don't want to read, we want to write. The format, we want to use a delta. We don't want to load, we want to save, and so on. And I know that the syntax is not familiar to you right now. Don't worry, it will become natural in time. And secondly, there's pretty nice documentation available out there that tells how to write it. And we'll cover that in the future anyway. So let me create a new container. How do we want to call it to be aligned with documentation from Microsoft? Let's call it conformed. All right, why not? So conformed. We might have this replicable and minifix. We don't need this file name, and let's see what happens if it would do the trick. So like so, I forgot about one thing. So I don't remember the syntax by hand. Oh, come on. Write this conformed container doesn't exist. And by the way, take a note that it is called here still file system. That's the old name of the container. Right now, they are just called containers. So let's create a new container. Let's do it manually. Oh, come on, I just call it container instead of conformed. So conformed, that's the name. And let me remove this one because we don't need this. Yes, confirm. And let me try to execute this one more time. Hopefully it will work this time. So something is happening. The data is being saved to my minifix directory inside conformed container as delta, and it succeeded. So let's take a look at our data lake. So we have this replicable directory, then a minifix, and yes, this is our data saved as delta. And take a note at the file size, less than 1 megabyte, while the original file that you read from Replicable API, the JSON one, it has 4 megs. So we were able to compress it to 25% of the original file size just by changing the file format. And from this point, we'll work on the Delta version of this data. And that's it for today. So today I talked about this Databricks stuff, what it is, where to use it. So you should remember that this is a platform that has a lot of features. We'll use it mainly to transform our data, that we have to provision the cluster, and please be aware of the settings of the cluster, just not to be surprised by the bill. And then we did this Hello World notebook just to read data from our JSON file and save it back as Delta. I know we just scratched the top of the Databricks, but we'll go deeper into this service in future episodes. So thanks for watching and take care.